Welcome. This is Radu, and I'm Rafał. And as you heard, we worked together for some time. Not anymore, but still we are here in Berlin Buzzwords. Thank you for that. And today we would like to talk to you about preparation of the Gödel set and actually untangling the dependencies, the circular dependencies that you have. What comes first, like the egg and the chicken problem. What comes first? The queries, the documents, whatever. For our use case here today, we won't use, if that's too small, let us know. Okay, let me try to make it a bit more, but let's not focus on the code, at least for now. Everything what we have here will and is already available on the GitHub. We'll show you the links and QR code at the end of the talk. And in general, we took a dataset, movie lens dataset, some of it, sample 62K documents, and we'll show you the process of how you would approach that stuff. Of course, it's not the only one, and you can find yours, but this is what we usually use for that kind of use case. So you would like to create the queries, know your data, look into what is there, and start exploring and creating the set that you are up for, and that will allow you to test and judge your application, your search engine, whatever, in that particular use case. During the talk, we'll also use, I would say, a few tools. Let's put it that way. One of the main will be Vespa as the database of choice. In addition to that, we'll use Navigator, a tool that will allow us to visualize that stuff that we'll show, and we'll use Python as the language of choice, which allows us to do these things quick and effective. And we prepared a few additional things, like the helpers here that you see in the Navigator, and additional helpers that allows us to index the data. Of course, I won't index the data right now. I have it already prepared, but you can repeat that easily. Then we deploy Vespa. It's very simple, just deploy, but we need to create an app for that and create some kind of configuration. And this is what I would like to show you now. First of all, give me a second. As usual, the gods of data, the gods of demo and data. This is a schema for Vespa. Nothing out of the ordinary. It's basically what you would expect from a schema for movies. ID, description, title, like genres, and so on and so forth. The things that may be kind of interesting is, for example, embeddings. During the talk, we'll use fast text model. So we created a field, which is of type tensor for that. And we'll also use an Arctic embedding, which is similarly configured here. I won't get into the details. Fast text will be trained on our own data. The Arctic access will be pre-trained already. And to that, we have the component defined in Vespa services XML that allows Vespa to basically do work for us. So download the model, download the tokenizer, and do it and work with it internally, right? So we have one less thing to do. So once the data is indexed, the app is there. Of course, as I mentioned, I won't do any kind of indexing. Any kind of indexing right now. But the code is there. We can start exploring. For example, a simple query that our users may send is, what are the years for the movies? Just to, oh, come on. Yeah, it's here. The caches. For example, the year coverage, right? So we have, no year or year distribution, something like that. So less than 1% of the movies do not have the year. We may want to clean up the data slightly just to have a better experience, right? To remove the garbage from the movies. Maybe it's something that we would like to get. We can also look at the genres and movies per decade, something that the users may want to slice and dice. That's not very important. Just some slicing and dicing to know what we have inside the data, so we can actually start creating queries. And the queries for that, they are pretty straightforward. You have select from movie, year higher than 0, group, some grouping and so on. Most of the search engines, all of them that I know at least, allow us to do that. The same when it comes to significant terms, for example, to know what the users may want to search for in the title. And the output would be pretty straightforward as well. Something like this, right? So man, that, when, from, whatever. Without pruning here, we may want to do some pruning, to remove stop words, common words, etc. So that will allow us to do some initial queries preparation. However, that's not everything. We want to enrich the data to be able to work with the broader set of queries, and that's the same way judge the documents that are returned by them. So for example, in our case, what we did is we use the TMDB, so the movie database. Our movies already has links and IDs from the TMDB database. So with the limitations of the free API calls, after 6 hours, we get the enrichment for the data, so additional fields. And based on that, we can do additional exploration. Like, first of all, check if the things were actually populated. So check for the samples of field coverage, for example, for 400 sample movies. So you can see like the overview, language, runtime, and countries were populated. We can assume, at least at this point, that the data after enrichment is quite clean and correct. We have the language and countries query. Again, the query itself is not very complicated, similar to what you saw already. So some grouping and selecting all movies with a limit, and showing that just to get a glimpse of what's there in this particular data to be able to create the queries. In addition to that, some runtime distribution. This is a bit more, let's call it sophisticated, as we assign colors to different runtime of the movie. You can see this in this particular very, very highly complex if statement. And that allows us to graph some nice things using matplotlib, at least here. And that's like the beginning of manual exploration. We can also, compare rankings and so on. We have like examples here, but the time is short, so I won't get into that. But, then you explore. Use BM25, use native rank, and so on and so forth. Try to come up with a set of queries that potentially your users may want to have. You know your users better than I do. I know mine, but, that's the thing. Then, when we are done with the lexical part of the search, we can go into the semantical part. So first, the fast text. It is a model that allows us, but we'll take the pre-trained one, not trained one, we'll pre-train it on our own data. And basically, it's pretty simple. We just output our movies into a single file, movie per line, combine title plus genres per movie. So it's pretty straightforward. Push it to the model. We use skipgram. It takes the center word and tries to predict the outside of the word, if I can say that. And it can be configured to also, let's put it, it's not the best word, typo tolerant, because it can build vectors not only from the whole word itself, but also from the n-grams. So as you can see on the, for example, training, the training is pretty fast. Come on, show that to me. Okay, as you can see, for example, from the comedy, here it took some different words as the ones that are similar or closest neighbors, right? The nearest neighbors here. And then once we have that and we index that to Vespa, and we did that just before the talk, you can see it, a few minutes of indexing, of updating the documents, we can compare them one to another. So BM25 against fast text. You can see the results differ. Which is better? Well, it's for us to judge, right? We can look at the documents, judge them, see which one is better, look at different queries. We have that as an example. But this model can be biased towards the data that we have. So let's take Arctic. We do the same thing. Arctic is from Snowflake, small model. We do the same. We run the same query and do the comparison, right? So that's not very visible, like, but okay. This can be run on your own, but believe me, the results in some places are closer to BM25, further compared to fast text, but still they show us something. They allow us to do some kind of queries and judgment, but maybe we can automate that.
Yeah, my turn.
Your turn.
Okay, so the whole idea of having multiple retrieval methods is just to diversify, because the core idea is when we rate documents, like query document pairs, we cannot for every query rate all the documents in our corpus. We need to choose the top n. And it's like, how do we choose that top n? And we want to have diversity here. So we want to use lexical, we want to use semantic, and with semantic, fast text is kind of biased on our data. The off-the-shelf model is biased on its own pre-training data. So we try to get like a diverse set of candidates so that hopefully we cover all the potentially relevant documents to our query. Our objective here is not necessarily to get a good ranking, but to get diverse candidates. Once we have this kind of in place, and we have some manual judgments, I think we can move on to using LLM-as-a-judge to create more judgments. So here I'm going to use this tool called Dataset Generator. It's part of Rated Ranking Evaluator. That's an open source tool maintained by the lovely people at SEAS who are here in front. Dataset Generator can help us generate queries as well as judgments. So if you're running already in production, then you will have query logs and things like that to draw from. But if you're starting from scratch, you don't have that luxury. So you'll have to create your queries first. So I'm just going to show you the config for Dataset Generator, or at least the one that we use here. So when it comes to generating queries, let's start with that. When it comes to generating queries, the question is, how do you expect your queries to look like if you don't have them already? If you have them, then you can check. And here we've identified two options. One is you can you have queries that look for a specific document, and the dataset generator can do that, can generate queries from documents, right? Can send a document to the LLM and be like, okay, pretend you're looking for this document, generate queries on top of that. We've done a PR where you can also generate queries from facets. So let's say people will look for comedy or romance or whatever, and then you can run a facet on a bunch of fields and then generate queries from that. And then you have a query template. The dataset generator will work with a bunch of search engines. Vespa is one of them. And we'll run those queries against the search engine, get the top n results, and send them to the LLM to judge. One thing that we've done here, and it might be a bit controversial, is we've sent them to the LLM in small batches. The reason for this is performance and cost, because if you're using LLM-as-a-judge kind of seriously, you're going to have a pretty huge prompt. And sending that with every query document pair can be expensive. So if you send like 8 or 10 documents, something like that seem to be the sweet spot as far as we've tested, then you can save a lot of performance and cost. Obviously, accuracy might suffer, but then we can compensate by using a more expensive model. So let's say if you go up from GPT Nano to GPT Mini and use batching, you're still gonna get better cost and performance as well as better precision than using the cheaper model with one query document pair at a time. That's at least our experience. So there are lots of best practices, so to speak, in terms of LLM-as-a-judge. That's a huge topic in itself. We have a prompt there in GitHub that should be a good start. One of those best practices is to tell the LLM to justify why it gave that rating to that document. And Dataset Generator can save that explanation. This is configurable. And then you get a file that looks like this, where you have the queries, the documents, and the ratings, as well as the explanations. And this file in itself is like another data set. And what we're suggesting here is you can take this data set, put that back in your search engine, and now you have a new data that you can explore, visualize, check for cleanness, and all the stuff that Rafał kind of showed earlier, or at least we scratched the surface.
Yeah.
So just some examples here. Let's say we want to see what are the most frequent explanations. The most frequent one is actually the default one from dataset generator, which is if we generate queries from a document, then it doesn't even send the document and the query pairs to the LLM. It assumes that the document is max rated because that was the source. Then we have other explanations here. Some are kind of more legit, some are less legit, like we're looking for an ID. Would people actually do that? I would assume not, but you know, for this argument's sake, let's say we do, but we can press on, right? Like if people look for an ID, the rating would either be perfect because we matched the ID, or crap, we didn't match the ID. It cannot be meh if we have like a 1, 2, 3 kind of scale. So we can check that, right? Like we can check how those queries look like. We can do facet by rating. And indeed, we can see that some ratings are 0, some ratings are 2. This is exactly what we expect. If you have more complicated facets, you can do visualizations like Rafał showed earlier with matplotlib. One thing I want to show you is that the navigator can also have like its own sort of native visualizations. And the way you'd use them is you can assign the response of the query to a variable. And then you can use this variable in your Python code. If you use polars, which is kind of like pandas, then the navigator can, you'd want to load your response in a polars data frame, make it the shape that you want to visualize, and then you would use these built-in functions like display chart, and then you can have nice charts. It will also detect, based on the shape of the data, what kind of visualizations fit. So that is very nice, and then you can put those in dashboards, you can share them and all that jazz. And you can kind of keep going, right? Like, are those max ratings actually max? Yes, they are. All of them are 2. That sort of stuff. Is the data clean? Can we make it better? Sort of rinse and repeat until we're happy. We're never going to be happy, but at least we're going to be happier, hopefully. That's kind of the gist of what we wanted to share. As Rafał mentioned, this is all in GitHub. There's the QR code for the GitHub thing, where you have like all this code, the kind of general flow of, get to know your data, clean it up, enrich it, generate judgments. And then the judgments themselves are another data set that you can do the same on. And also the tool that we talked about. There's this navigator tool, there's rated ranking evaluator with the dataset generator, and of course Vespa. If you want to learn more about Vespa, we'll be at the booth. And we're also going to have our own conference in London in September, so there's a discount code there, also at the booth. Like if that is something interesting, we'll be around. And I think we have a couple of minutes for questions if you have any. Was okay? Yep.
Thank you very much. Any questions from the audience?
I think if I have to answer now, I'll have to basically
Kiss you.
Thanks a lot for the presentation. I have a question about the LLM-as-a-judge. I was wondering, first of all, like when we typically do ranking, we try to include extra signal to the ranking. First of all, like the add to cart rate. For example, like I'm coming from e-commerce platform. Because sometimes the add to cart also gives quite good signal about which product we should rank first. Do you have any idea how we can include kind of like additional signal like add to cart into the LLM-as-a-judge?
Yeah, so I think the best idea is to keep that in your documents, and when you send the documents to the LLM, you can include all that metadata that you think is relevant for the LLM to judge the rating, and then in the prompt you'll need to probably say how important it is that things were added to cart, and probably want some examples and some rules that define like, what is a good result, what is a bad result. Yeah, so that would be the rule of thumb, I would say.
Thank you very much. That was like time for exactly one question. Thanks a lot. Thanks a lot, Radu. Thanks a lot, Rafał.
Thank you.
And yeah, big clap.